So they followed the contour of the land. And what they did then was to build these ditches, they'd follow the contour so they could dig the dirt out of one side, drop it on the other side, and that's your ditch. So you had to move half the dirt to make your system. Now, of course, you're digging out topsoil and stuff on the one side, dropping it on the other side, so it kind of might have leaked a little bit, but that's the way you had to do it, because we're going to run a ditch from Cardston all the way to Medicine Hat. And water can only drop so fast, otherwise it starts eroding really quick, so it's got to be, so they just follow the contours. So what do the farmers do? We're going to follow that ditch. So we got to irrigate below the ditch, because back then there's no such thing as pumps. So everything is below the ditch that they're going to irrigate. So this is what they come up with. Drag a head ditch, throw a piece of canvas in. So if we can imagine, the main ditch is where those guys are standing. They'd have a turnout structure, basically a couple of boards in the ditch that they could lift up or pull a gate open. Water came out into this little head ditch. You throw a canvas there, and you go with a shovel, and you dig the dirt out of here and let the water run. And you'd let it run and run and run, and it would go wherever it wanted to go. And then you'd take your shovel, fill it back in, dig another one, and let it go. So most of this was all pasture and forage grasses and that type of stuff back then, because you just didn't have the efficiency of getting water to go where you wanted to. Early 1900s, we finally got a little bit of machinery coming in. We got steam engines. We got a chance to start leveling the land. So now when we cut this hole, it's going to follow an exact channel. It's going to spread out and fan out. Now we can start irrigating grain crops. And if you're in the Raymond-Tabe area, sugar beets, because they're in rows. And we could start cutting ditches all the way along here. So that's really what we really did until probably the late 40s. That's all that we had, was basically flood irrigation, following the contour of the land. And then when the PFRA came in, they started this land leveling program, where they had hundreds of staff members running around southern Alberta, actually measuring out every 100 feet, chaining out a field, putting stakes every 100 feet in an entire quarter section, and then cutting and filling and coming in with land levelers. And they land leveled thousands and thousands of acres of southern Alberta so that this could now become efficient. The next thing they did was we come along and we started using this stuff called gated pipe. So now we didn't have to dig into the dam itself. We just come along and flip a switch. So the water goes through the pipe. You want it to run down your field, you just open the gate and out come the water. Life was great. You didn't have ditches that were flooding and breaking open. This stuff would actually control the volume of water much better going down the field. So now we're becoming way more efficient in getting the water to the crop where and when we needed it. These gates were actually even designed for 36 and 42-inch potato row spacing, so that you could run it down the runs of your potato rows. So, big invention. As Len mentioned to me earlier, the real reason a lot of this stuff happened was right after the First World War, or Second World War, and aluminum had been found. And where did they make the first stuff? In Vernon?
For irrigation, Alcan and Vernon.
Reasons people do.
The main plan for just what all the aluminum pipes. Not the fittings. The fittings came up from the state.
But all of a sudden we got a Canadian company making aluminum pipe. So that brought us to the next invention. So I remember that up until the 50s, power and stuff was a big issue. And we had a rural electrification came through, which basically the provincial government says, not just cities and towns should get electricity, but everybody out there should have electricity. So they started running power lines all over the place. Along power lines, and they started running gas lines. So now every farmer had a power pole. We had electricity. Well, if we got electricity, why do we want to do that when we can buy a pump and we can do this? So this is hand move. And this is kind of the first real invention of sprinkler irrigation in southern Alberta. 40-foot length of pipe, impact sprinkler, hook it up to a main line, fire up your pump, turn it on, crank this valve open, water comes out of your sprinklers. Remember, you got a line of these things for 1/4 mile long, 1/8 of a mile long, and here we are. Technology is wonderful. Every 8 hours, shut this valve off, and all you had to do is just pick these things up one at a time and move them 60 feet. Hook them back up. Mom and Dad loved it. Kept you out of the barn because you were too tired to be a nuisance. You wanted 12-hour sets. Your dad wanted 8 just to keep you busy. But it was a great invention because you didn't have this, and the efficiency of getting the water to the ground was much, much higher with this hand move than what we ever had. It worked. It made you thirsty. So the next thing that came along, and this is probably, now we're talking about late 1950s, early 1960s, wheel moves. Somebody out of their great wisdom said, why do we want to carry that stuff when we can roll it? So they did exactly that. They basically took a hand move system, put a set of wheels on it. There'd be a motor in the center of it that you'd fire up the motor, put it in gear, and this thing would just roll forward. 7-foot wheels is what this one is. They came in 7-foot and 5-foot. Exactly the same thing. Every 60 feet, you want to move it. So a 7-foot wheel, roll it over 3 times at 60 feet. 5-foot wheel, roll it over 4 times at 60 feet. You always wanted to have the sprinklers upright, so that's why you had to get it exactly 60 feet. And when they weren't, you end up straightening your lines and stuff. But what a great invention, because now instead of taking 2 or 3 hours to move hand move, you could move an entire quarter section for these things in an hour. All of a sudden gave the producer a whole bunch more time to do what they should be doing, and that's farming, and that's marketing, and that's doing other things that they're really good at. So this was a huge invention, and we had thousands and thousands of these throughout southern Alberta because this was the way to go. And if you didn't have this and you still had that, you were not somebody. So this was a great invention that really took off, and if you looked at the graph that Shelley will show you later, irrigation really started to grow in the 1950s and 60s, and it was really because of this. And our efficiency of getting water on the ground started to grow because of this. And the other thing that I mentioned in the other group was when I started in 1980 with the provincial government, one of our biggest problems was salinity. And we estimated at that time probably 20% of our land that we irrigated was saline. And most of it was because of that. Gravity irrigation, flood irrigation, earth ditches that seeped and everything. When we finally started catching up to technology, when I quit, we estimated it's less than 2% is saline. Mainly because we're efficient, we're not having it getting in the ground, and we're not bringing up the salts that we used to bring up out of the ground. So big change in technology. So let's go to the next one. So the next thing that came along was a thing called center pivots. And over at the display there, we'll talk about look at some of the different sprinklers and stuff. But center pivots come out in the early 1960s. And basically what it was is they took that wheel move, and somebody got a really cool idea that said, let's make it go by itself. So they built it 13 feet tall. They put the same sprinklers on as what we had on the hand move onto it and made it go in a circle. Anchored in the center, and most of them were kind of a piston drive and kind of a ratchet and just kind of pulled itself and walked itself around the field. The problem with it though is you couldn't use the same sprinkler on every single nozzle because they did the same thing. These sprinklers are every 40 feet. So on the first center pivots that came out, water drives, they put them every 40 feet. But you got to remember, at the very far end of a pivot irrigates way more acres than the one closest to the center because it's going in a circle. So what they do? They just put a bigger sprinkler out there, which meant you had to run incredibly high pressures. probably in the 100 to 120 pounds of pressure to get enough pressure at the very far end to run that huge sprinkler. It worked, and everything went really well for quite a while until energy prices started clicking in. And it was kind of a dual thing. 2000, we end up having kind of a drought, 2001, major drought here in southern Alberta, where farmers were limited in the amount of water they were allowed to use. So that started pushing that efficiency side, which said, why sprinkle up here when we can get it down here? So they put these drop tubes on. Big innovation with the different nozzles in the 1980s and into the 90s. A whole number of different companies come up with different nozzles to start throwing the water down below the trusses of the pivot, get it close to the ground. Instead of being 13 feet high, now we're going to get it down to about 5 or 6 feet high. Increase our efficiencies from up above probably 75%, so 25% losses, to dropping it down. We're now into about 82% or 18% losses, huge efficiency gains. So by doing that, efficiency changes, all of a sudden by having a drought, we weren't really impacted as much as we would have been in the olden days because our efficiencies are so much better in getting the water to the ground. The second thing that really kicked in then was a fellow by the name of Ralph Klein. Decided to deregulate energy, electricity. So in 1999 or 99, you could buy electricity out of Calgary Power for 4 cents a kilowatt, all in. Mainly because Calgary Power, and Len kind of mentioned this to me earlier, was they sold their power in the wintertime for heat. They had all kinds of extra power in the summertime. So they ran around in the 90s and sold contracts to everybody who'd listen for cheap power for the summer rates. So they got all this cheap power. We deregulate in 2001, and overnight electricity rates went from 4 cents a kilowatt to 21. Plus you had a rate rider, plus you had a transmission charge, plus you had, and all of a sudden electricity bills were going up by 5 and 6 and 7 times. Immediately, irrigating up here at having to have 80 horsepower to down here with needing 30 horsepower was a no-brainer. And the changes were dramatic. So even though we saved a huge amount of water by going to low pressure, and some people will say, well, that's what drove the change was efficiency gains. I'd argue that it wasn't the efficiency gains, even though by default that's the best thing that ever happened to us, was electricity charges. And because of that, now we've got a whole bunch of conservation things going on, which is even better. So when we talk conservation, now we're coming out with drag hoses, subsurface drip, a number of different alternatives to increase your efficiency getting the water to the ground even that much better. Now, I always got to throw a caveat out though, that do it for, if you're thinking of changing because you want to save the world, do it for the right reasons. Your ag producers, you're supposed to be there to grow a crop. By putting these things in, they really do save a lot of water because now you're putting it right on the ground. Your efficiency is probably getting into the high 90s as far as getting the volume of water into the ground. But are you getting the right amount of water in the ground? And are you getting it to the right places? Not very many people farm in circles. So if you're going to put this on a center pivot that goes around and around and around, and you're farming back and forth, this is going to ride up on top of the crop, which is exactly what you didn't design it for. You designed it to put the water on the ground. So ride it on top of your canola crop, or ride it on top of the ears of your corn crop when you designed it to get it on the ground. So do it for the right reasons. If you're doing it because you've got alfalfa seed production and you want more flying time for your bees, maybe that's a really good option for you, is to get it on the ground. The other thing you got to be careful with these though, is you don't know if they're plugged until harvest time. To put a proper filtration system on, we're probably talking $40,000 plus for the filtration system. So if you're doing it for the right reason and it's because of crop quality, because of crop production, $40,000 is just part of doing business. But if you're doing it just to try and save water, give yourself a really good thinking. Is that really what you want to do it for? Because the other thing is that most of these will be designed for about 400 to 600 gallons per minute. As agronomists and farmers, you know that you have to get a certain amount of water to the crop for it to grow. So this canola crop right now, it's just bolting 4 or 5 millimeters a day it's using. When it's in peak production, it'll probably be up into 6.5, 7 millimeters a day. Windy day like yesterday could be 8.5 millimeters a day. If this is designed for 600 gallons a minute, it cannot keep up to that crop. Physically impossible unless, as Len said, if you got a 35-hour day, it's just right. So again, design it for the crop that you need, so be careful on how you do that stuff. Subsurface drip, again, great technology, huge water savings if you don't have rodents. And again, do you know when it's plugged? Until you see it. So if you're doing it for the right reason, if you, again, alfalfa seed production, you got some special crops that you really don't want the crop canopy wet, this may be a huge opportunity for you. So with that, any questions?
Irrigation districts still aren't charging by the acre foot, are they?
Irrigation districts will probably never charge by the acre foot.
So then this really doesn't make sense.
That's correct, because you're charged per acre. And the other thing, unless you're a private irrigator, private irrigators hold their own license. So if you're irrigating off the Old Man River, the Belly River, Willow Creek or something, you would have your own license. And your license would be for X number of acre feet. So if you have something like this and is really, really efficient, you may be able to add additional acres using that same number of acre feet. The irrigation district holds the license for all of you combined. So even though you might become really efficient, doesn't allow you to add more acres. It may allow the district as a whole to add more acres, but not you as an individual. So efficiency, why have we increased acres in southern Alberta over the last, especially last 10 or 15 years? Most of the irrigation districts have gone through a plebiscite to expand their acres, is because as collectively, almost everybody is going to this, and the efficiencies are huge efficiency gains. Because of that, we've been able to expand the industry as a whole. But as an individual, you can't take water savings because that's not how you're licensed.